welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about Nanogel for Nanomedicine. Now, our expert Professor Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Icon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics and biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without a skip.
Now, we know that tuberculosis happens to be one of the dominant infectious disease in the developing world. It is not there to such a large extent in the developed countries in the West, but in the developing countries, it continues to be a big health threat. Now, for the treatment of tuberculosis, a treatment protocol has been designed by World Health Organization that is more or less followed by all the medical practitioners. Okay, in that protocol, 4 medicines are used to control the spread of this parasite, bacteria. Out of them, isoniazid happens to be one of those medications. Now the issue is, this is again a model experiment, and try to see whether isoniazid, one of the tuberculosis medicines, can it be delivered through nanogel to the site. Because in the conventional treatment or medication protocols, what happens is we tend to overdose the patients with the antibiotics because the bioavailability of the antibiotics at the site of the infection is very low, because a lot of it is excreted and it gets metabolized inside the liver and is not available to the actual affected site. So because of that, there's an overdose of medicine given to the patient, and because of that, there is secondary effects of the headache, dizziness, patient feeling uncomfortable, nauseatic feeling, increased BP, and all these things happen. The idea is deliver it through a safer route to the site at a lower dose, so that the patient discomfort is removed. That is the whole idea. Okay, so this model drug now, tuberculosis drug, isoniazid, will be encapsulated inside the nanogel, and we'll see its efficacy. That is the objective of this study now. So synthesis of the nanogel. Now we are not going to use gelatin. We are going to use an inorganic polymer, polyacrylic acid. So what is done is nanogel particles are prepared again through photo radiation, gamma radiation, by polymerizing acrylic acid in the presence of aqueous solution of polyphenyl pyrrolidone. Molecular weights are all given here at the bottom.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And then there are 2 samples that are prepared. One is polyacrylic acid, PVP. One is PVP with ethanoic acid. So there are 2 samples that polymers we are preparing here by cross-linking. So we have the mixture of both PVP and AAC here, AAC and PVP, polyacrylic acid, polyphenyl pyrrolidone, or PVP and ethanoic acid. They're both dissolved in citric acid buffer here, with pH 4. Different ratios are given here, and total polymer concentration is also shown here. Then they're placed inside the sample cells and irradiated with gamma rays, with standard cobalt source at ambient temperature. All these experiments are ambient temperature experiments. That cross-links it, and you have the nanogel ready there. Now, those are dispersed, ultracentrifuged for 1 minutes to 1 hour, and now this can freeze dry it and store it for future application. As simple as this. Very simple method, very simple protocol. That is the blank nanogel. Now we have to do the drug loading. So what we do is we have now the freeze-dried nanogel available with us. You dispersed it in phosphate buffer, a different pH here. Then isoniazid is dispersed in a solvent. Again, it's water. 1:1 ratio of drug and nanogel particles. Mix it. They're all prepared in the phosphate buffer solution. Then you will have colloidal dispersion. This isoniazid will get translocated into the nanogel particles through this protocol of ultracentrifugation, and when they are homogenized over a period of time. Okay, so after this unloaded NIH, or which is the isoniazid, in the solution you can determine spectrophotometrically UV visual spectroscopy experiments done at lambda 260 nanometer will tell you clearly how much isoniazid is free, which has not got loaded. The rest is inside the gel. Okay, so it's possible to know what is the drug loading. Okay, so this is a very as simple as this. Is basically you're adding two components. One is the freeze-dried nanogel that we have already prepared. Other one is your drug molecule, both in phosphate saline buffer. 1:1 ratio. Mix. Keep them mixing for around 48 hours at room temperature. Centrifuge it. Your isoniazid gets translocated into the nanogel. Take out the nanogel through ultracentrifugation, freeze dry it, and store it. Check the supernatant for unreacted or free isoniazid molecules, and you'll get the concentration of loading.
I hope you like this video. Further, I would like to give you an important information that Nanoscience and Technology Consortium organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel on Star and also hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.